Welcome everyone, I am JJ. Let's tackle an example problem. So we're going to find Ix for this area. We did this using a differential strip that went parallel to our axis of interest. We put in a rectangle going this direction. In the previous video, we're going to come and do this using an area that goes perpendicular to our axis of interest. Sometimes it's a lot easier for us to deal with in here. For this method to work though, that differential strip has to be sitting on our axis of interest. So for example, on this one, I could get Ix in here. My differential strip, if we sketch it in now, should go straight up and down. I'm going straight up and down. We would get this differential strip. Super over exaggerate how big it is. But that sits on the x-axis. I could use this to get Ix. My y strip would go perpendicular to y. You go this direction. Because of this negative space up here, my axis or my strip would have to start here and go to the left. It's not sitting on the y-axis. I could only do this for Ix. We can do that. That's all we're asked for, Ix. The width of this strip is dx, and the height of this should just be y. But what we're going to end up doing is saying, I'm going to use I equals the integral of di. This is the same idea that when we used ADA, or our area and our differential area, when we integrated that, we got a total area. If I find my moment of inertia of a rectangle in here, I can get to my moment of inertia of the entire thing if I integrate everything. And I know that my moment of inertia for a rectangle, I should just be equal to I for a rectangle for an axis that it's sitting on. We'll call that the base. It's just going to be equal to base times height cubed over 3. Base always goes parallel to our axis of interest. Height goes perpendicular to it. So our height would be y. The base is dx. So my di, my moment of inertia of our differential strip, should be base dx times my height, y cubed, over 3. I still have a y dx in here. I can make a substitution. But conveniently, I have a y cubed statement in this. This is the same thing as, well, y cubed is 2x. I'm rearranging this times dx over 3 is my di. And really, all I have to do then is come in and say, well, let's integrate that. My moment of inertia, I, should be my integral of di. And I'm going to go for my smallest point. This is a dx, so I want to go from my smallest x, 0, out to my largest x, 4. 0 to 4 of 2x over 3 times dx. Or this is going to get me 2x squared divided by 3 times 2. Those 2's are going to cancel. And we're left with x cubed or x squared over 3, evaluated from 0 to 4. Our Ix value is 5.33 inches to the 4th, which would be our final answer. Again, there are other ways we could come in and do this. If you were looking for an example using dA in there, I is x squared dA. Take a look at a different video. If you're looking for things using the parallel axis theorem, those will be later videos. Go in and take a look at those. We'll get you through that. But hopefully this was useful. If it was, hit those like and subscribe buttons. Stick around. Let's get you an A with JJ.